Today I'm going to show you how to use SoundCheck's stimulus frequency cursor. This is a new feature we introduced in SoundCheck 23 that lets you see the exact frequency of any transient event on a recorded time waveform. This feature can be used with frequency stepped sweeps, or sweeps, frequency log sweep, log amplitude sweep, two-tone options, intermodulation and difference frequency, and loose particle and enhanced loose particle waveform, and time envelopes. Here, I have a short sequence I'll use for demonstration purposes. The first part uses play and record acquisition and harmonic track analysis, and the second part recalls some enhanced loose particle waveforms. Let's start the sequence and take a look at our recorded time waveform. We can see in our table here that the record delay is 1.11 milliseconds, and we can clearly see that down here in the waveform graph. And let's expand this graph so we can look at this new feature. Now, one thing that's important to know when you're using this feature is that delay compensation must be added to our waveform. If I try to enable the stimulus frequency cursor now, you can see that it's grayed out. So, I'll just add delay compensation in our analysis step. You can see here on the Delay tab, there's a new function called Output Auto-Delayed Waveforms, so I'll select this and apply. If you keep your eye on the memory list, then you should see a new waveform appear with the name Auto-Delayed Recorded Time Waveform. Let's bring this over to our waveform graph. And we can see this has essentially moved the start of the recorded time waveform to time equals 0. Let's remove the original one. Now we've done that, I can drop my stimulus frequency cursor onto this recorded time waveform. And we can now see that we have the time and magnitude coordinates for our auto-delayed waveform. And here we have the frequency value. You can see these values changing as I drag the cursor across the waveform. Now let's take a look at how we can use the stimulus frequency cursor with loose particle analysis. We'll continue running the sequence, and it's going to recall a previously recorded time waveform and perform an enhanced loose particle analysis on it. Here we've got the recorded time waveform, and down below is the enhanced loose particle waveform. Let's add our stimulus frequency cursor to the enhanced loose particle waveform. You can see that it's already enabled. That's because by default, the ELP waveform is already delay compensated. So we can jump right in and enable our stimulus frequency cursor and see the readout here. I can also use some of the other cursor functions like snap to max to see where the largest transient is on the graph. It's telling me it's at 200 Hz. Again, I can drag the cursor and see the frequencies change. We can see just by looking at it that the largest concentration of loose particle transient events occurs between 132 Hz and 250 Hz. So that might help us understand a little bit more about the behavior of the loudspeaker. So that's how we use the stimulus frequency cursor. If you want to learn more about this feature, check out the SoundCheck manual or ask your sales engineer.